Hello everyone, welcome to Jason Tech. I'm Jason. The last video introduced the Tomahawk chip used in the span position of the data center. In this video, let's talk about the Jericho series chips used by Broadcom data centers for routing scenarios. My channel shares high-level tech topics related to data centers, talking you to improve your horizons and skills. Follow me, turn on the little bell, and don't miss any high-level videos. Let's take a look at this picture, which describes the network from the office point to the one and then to the data center. Different network components can be covered by Broadcom chips. This notes of the main router used the chip Jericho or Jericho plus Roman. This Roman is mainly the accompanying fabric chip, which mainly provides 192 50 gig SerDes and can provide a massive fabric I/O capability of 9.60 bps. It is mainly to connect multiple fabric boards to meet the full line speed of 14.4 Tbps cross-cart forwarding. If you are interested in the internal architecture of the chip, you can take a look at the article introducing the Jericho 2 C+ chip architecture in the introduction below the video. In fact, in these early years, routing scenarios were usually undertaken by high-level routers with CPU plus FPGA or CPU plus NP architecture. However, as chip capabilities become stronger and stronger, at present, except for some interfaces such as POS or CPOS that can't be replaced by Ethernet switches and large routing tables such as several megabits, common routing scenarios use Broadcom's Jericho chips can be replaced. Let's take a look at the model weight and relative characteristics of the Jericho chip in this routing scenario. So far, the Jericho series chips have two generations. The model is easy to remember because it is not the son of Broadcom. So the name is not like the Prince series of the Broadcom, such as Trident 568 or Tomahawk 569. No, instead, it uses the beginning of 88. J Plus and J2 and are 88670 and plus 10 to 88690 respectively. Jericho 2 J2C Plus is 88850. You can see what is written under the chip. At present, many chassis have core switches. Chassis 1 are made of Jericho series with the gradual enhancement of the small core Tomahawk compatibility. The Jericho series module switches have been gradually moved from within the DCN to between DCS. Let's start with the first generation Jericho chip 88670 and introduce them one by one. The first generation of the Jericho chip, single chip 720 Gbps, removes the library bandwidth I/O. The available bandwidth is 680 Gbps. It can produce a variety of boards from 10 gig to 100 gig. Different boards have different shapes, so the number of chips placed on a single board is also different, not the same. For example, for a 48-port 10 gig Jericho board, generally 48 multiplied by 10 means 480 Gbps, less than 680 Gbps. So one chip is enough. And some manufacturers even provide several 100 Gbps ports. However, the 36-port 100GE board is 3600 Gbps. So at least 6 Jericho chips must be placed forward at full line speed. The catch of a Jericho is generally 4 GB, so with 6 Jericho 36-port 100G boards, so you can calculate it out. Yes, that is 24 GB. That is why many data centers chassis core switches in the industry claim a large catch of 24 GB, just accumulated with chips. Some guys will ask, after talking so much, it's all about single board cards. Shouldn't the chassis tab be a multi-product? So how can cross cards ensure line speed forwarding without bottlenecks? This question is very good. This is the fabric element to be set, FE for the short. It is used as a switching network board to connect multi-line cards. This FE has different series and models. Currently, the BCM88770 used for Jericho generation is 3.6 Tbps. Sometimes, multiple chips are placed in the FE to meet the line speed requirements of different boards and cross-card forwarding. The functional features of the first generation Jericho, such as MPLS, VX line, MPLS-SR, PBR, OEM, etc., can be naturally supported to meet the needs of data centers core or DCI scenarios to replace routers. For the Jericho Plus series of chips, the most important changes are 2 points. First, the performance is increased to 900 Gbps. This way, the single board can save some chips. In addition, in terms of feature support, PPPoE is added. The second generation is a leap forward compared to the first generation Jericho. The performance of a single Jericho chip can reach 9.6 Tbps. Well, in this way, the single board card of the chassis switch can achieve 48 100 gig. At this time, to enjoy the chip bonus in the scenario of DCI interconnection, the top internet customers simply use Jericho 2 to make a box instead of chassis. By replacing high-level routers with box switches, one box provides 96 100 gig interfaces to run SR video, which not only greatly save costs, but also have cross-card forwarding black holes and delays in the chassis type devices problems can also be solved perfectly. In terms of software features, 400 gig SAT and INT at the operation and maintenance level are added. So far, the latest generation of Jericho is Jericho 2C Plus, which has higher performance and more powerful functions than Jericho 2, leading the development of next generation high-density 400G chassis type and box type network equipments. In particular, it's not a problem to replace high-level 100G routers in DCI scenarios. Jericho 2C Plus chip model BCM88850, single chip 14.4 Tbps. The single board can be output 36 ports of 400 gig. With FE BCM56790, 9.6 Tbps with the core I/O can create high-density 400 gig chassis network products. At the same time, the box type 100 gig, 200 gig, 400 gig DCI scenarios are also capable, such as 144 100 gig or 72 200 gig, 32 200 gig plus 72 100 gig, 16 100 gig plus 32 400 gig, which can save lots of money and power consumption instead of DCI chassis routers or DCI chassis switches. And even in the scenarios where backbone DCI encrypted transmission is required, Broadcom also specially launched the MacSec function for the hard encryption. It is also worth mentioning that the combination of ZR in this scenario can also greatly reduce electrical layer equipment of the optical transmission equipment of the backbone network, and greatly reduce the cost of large bandwidth DCI interconnection. There is a lot to say in this piece. If you are interested in ZR and ZR Plus, please leave a message to see if it's necessary to make a special video to tell you about ZR and ZR Plus. Alright, that is all for today's video. Also leave homework. How would you briefly describe the Broadcom Jericho series chips? What are the main usage scenarios? What are the current mainstream chip models and bandwidths? What kind of density devices can be made at most? What's the differences? I will put the answer in the introduction. Please leave a message if you have any questions, and see you next time.